Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. In today's presentation, we'll be talking about paired samples t-test. Paired samples t-test is one of the three forms of t-test. Why do we need paired samples t-test and what kind of problems does it help us solve? Remember the three golden words, before and after. Whenever you have a before and after situation, you can use the paired samples t-test. Let me give you a couple of examples to make you understand this better. If you want to check whether there is a change in the blood sugar level of a patient before taking breakfast and after taking breakfast, we can use paired samples t-test. If you want to check whether there is a change in the weights of the patients before taking a weight reduction pill and after taking weight reduction pill, you can go ahead and use paired samples t-test. Thirdly, if you want to check whether there is a change in the performance of students before training and after training, here again, we can go ahead and use the paired samples t-test. If there is a change in the performance of the students after taking training, it means that the training is effective. If not, it means that the training is ineffective. Similarly, if you want to check whether there is a change in the response rate of the customers before campaign and after campaign, here again, we can use the paired samples t-test. If there is a change in the response rate of the customers after giving a campaign, it means that the campaign is effective. So this is where we use the paired samples t-test for the same set of people before and after. To show you how paired samples t-test works, I will be working on a data set which is called as diet study. Let me click on file menu. The second option here is open. I will choose the very first item, namely data here. This goes to a folder which is called as the English folder. Let me choose the file called as diet study. This is the file that I'll be working on, dietstudy.sav. When I open up this file, you will see you have information about patient ID. You have 16 patients who have come to the hospital. We know his demographic details like what's his age and what's his gender. We also have information about triglyceride level, which is a form of lipid or fat that is present in the blood. I will not be paying too much of attention to triglyceride related variables because that is not the purpose of analysis here. May I draw your attention to the variable weight here? You see here, there is a weight variable here. It says weight 0. What happens here is when a patient comes to the hospital, he is made to stand on the weighing machine and his weight, his initial weight is recorded. The number 198 means that the first person's weight is 198 pounds. This is the initial level of weight before taking drug. What is done after this is he is given a weight reducing pill and we ask the patient to continuously take this drug for 1 week. After 1 week of taking this drug, we record the second measurement for his weight. When he stands on the weighing machine now, his weight is 196 pounds. Similarly, this procedure goes on and we record his weight for, this is for the first week, this is at the end of the second week, this is at the end of the third week, and this is at the end of the fourth week. So we record 5 different measurements of weight. This is the initial weight before taking drug. This is the weight of the patient after first week. This is the weight of the patient after the second week. This is the weight of the patient after the third week. And finally, what you have is weight 4, which is the weight of the patient after 4th week. Now, there are 2 questions that we are interested in asking. First, is the drug effective? Second, from when did the drug begin to take effect? To answer these two questions, let me use the paired samples t-test. To perform the paired samples t-test, I will be clicking on the option Analyze. I will choose the option Compare Means. Here, the last but one option that you see is what is called as the paired samples t-test. Let me choose the option paired samples t-test. As you can see here, I am expected to enter a pair of variables. I can't enter merely one variable. I need to supply two variables. Let me take the initial weight and the final weight. I will choose these two variables. This is the initial weight of the patients. This is the final weight of the patients after taking drug. I will choose the option OK. SPSS produces the output in the output window. You see three important tables here. Let's look at the descriptive statistics. The very first table says that the initial weight, the average initial weight of the patients is 198 pounds. After taking the drug for one continuous month, the weight of the patients now has reduced to 190 pounds. So approximately there is a reduction in the weight of the patients to the extent of 8 pounds here. The sample size here is 16. The standard deviation is very, very close to each other. The standard error of mean is also very, very close to each other. I will delete paired samples correlation because there is no point looking at correlation here. That is not the purpose of the analysis here. I will move on to the paired samples t-test. You can see here the initial weight minus the final weight is calculated here. The initial weight is higher and the final weight is lesser, and the mean difference is reported as 8 pounds. What SPSS does is it also reports the standard deviation, the standard error of mean, and very, very importantly, it gives me the 95% confidence interval for the difference of the means. It says 6.5 and 9.6, which means that this difference in mean, that is 8 pounds, will lie within the range of 6.5 pounds and 9.5 pounds. I can see the t statistic value and the degrees of freedom, but finally, what is important to me here is the p value or the significance level. I'm getting a significance level of 0.000. I have to compare this with 0.05. Since the p value is less than 0.05, I can go ahead and conclude that there is a significant difference in the weights of the patients before taking drug and after taking drug. So it says that this mean difference of 8 pounds is significant, and therefore I can go ahead and conclude that the drug is effective. So this is the way we can perform a paired samples t-test for a set of patients. We have recorded several measurements of weights. Let me show you the data set again. This is the initial level of weight, and after each successive week, we are recording their weights to see what is the reduction in their weights. We have been able to answer the first question, that is whether the drug is effective or not. No doubt the drug is effective because we are seeing a reduction in weight of the patients to the extent of 8 pounds. Now, at this stage, I want to take a pause and ask the second question. Yes, the drug is effective, but the question here is, from when has the drug started to take effect? Some drugs begin to take effect immediately. Some drugs takes time to kick in, which means that the effect of drug may be after 1 week or after 2 weeks or after 3 weeks. I do not know. To answer this question, as to from when has the drug begun to take effect, what I will do is I will again perform the next level of paired samples t-test. Let me go to the analyze menu. I will choose the option compare means. There are different options here. I will choose paired samples t-test. I have already entered a pair of variables. Now what I need to do is enter other variables here as well. Let me maximize this window for you. You can see here, this is the initial weight and the final weight. I will be choosing the next pair, initial weight and the first week. Let me also choose the next pair, that is the initial weight and the second week weight. Initial weight and the third week weight. When it comes to the first pair, let me select the first pair and push it down. Yes. Now what we are doing with this is answering a simple question. Has the drug started to take effect immediately, or is there a lag period before the drug begins to take effect? So I've entered 4 pairs of variables: initial weight with the first week weight, initial weight with the second week weight, initial weight with the third week weight, initial weight with the final weight. Let me click on the option OK here. Interestingly, you will be able to see the descriptive statistics. When it comes to the first pair, initial weight and the first week weight, you can see here the initial weight, the average initial weight of the patients is 198.3 pounds. It has reduced to 196 pounds at the end of the first week. Let me look at the second week. Initial weight was 198.3 pounds. After 2 weeks of taking drug, the weight has reduced to 194.1. So approximately there is a difference of 4 pounds by the end of the second week. Let me look at the third pair. 198 was the initial weight. It has dropped to 192. Approximately there is a difference of 6 pounds by the time we hit the third week. And we are already familiar with the fourth pair of variable, that is initial weight and the final weight, which is 198 and 190 respectively, which means that there is a reduction in the weights of the patients to the tune of 8 pounds. I will again ignore the paired samples correlation. I'm not interested in this. Let me scroll down to look at the paired samples test. This is very interesting. So when you take this particular weight reduction pill, weight reducing pill, the difference in the weights that you notice is 2.25 pounds at the end of first week. Let me look at the very last column here, the p-value. The p-value is less than 0.05, which means that this mean difference in the weights for the first week is very, very significant. It is a real difference and it is not happening by chance, which means that the drug has begun to take effect from the first week itself. Right away, it has started producing results, which is we can expect a weight reduction to the tune of 2.25 pounds. What happens to the second week? You can see here initial weight and the second week weight. The weights of the patients has reduced to 4.25 pounds. Is that significant? Look at the last column, please. The p-value here is 0.000, which is smaller than 0.05, and therefore I can conclude by saying that this mean difference is also significant. Let me study the mean difference of weights between the initial weight and the third week, which is 6.25. Again, that is significant. And we are already familiar with this last pair, but that is we are comparing the initial weight of the patients with the final weight, and we are able to notice a difference of 8.06 pounds, and that again is very, very significant. Now, with this, I have come to the end of today's session. In today's video, we have looked at paired samples t-test. We have looked at the benefits of paired samples t-test. We have looked at how do we interpret the value of P for the paired samples t-test. I thank you very much for watching my presentation. I request you to subscribe to my channel and please share this video with your friends and relatives. Thank you very much. Have a good day.